Find the critical percentage of steel for MX grade concrete and FEY grade steel in the working stress method. Working stress method is a method used to find the stresses in concrete and stresses in the steel. They can be checked with the permissible stresses. Let us draw a rectangular beam cross section. Small b is the breadth of the beam. Capital D is the overall depth. The reinforcement is provided in the bottom layers. So these are the diameter of the bars. Effective depth small d is the vertical distance from top of the beam to the center of this reinforcement. This beam is divided by a line is known as neutral axis line. Depth of critical neutral axis x. This is rectangular beam cross section. Let's draw the strain profile. This is strain in concrete. This is strain in steel. Strain in concrete is equal to sigma CBC by EC, where sigma CBC is the permissible compressive stress in the concrete due to bending. EC is the Young's modulus of concrete. Strain in steel is equal to sigma ST by EST, where sigma ST is the permissible tensile stress in steel. EST is the Young's modulus of steel. Now draw the stress profile. This is the stress distribution on the beam. This is sigma steel divided by M, where M is the modular ratio. This is sigma CBC. M is the modular ratio, which is the ratio of Young's modulus of steel to the Young's modulus of concrete. It can also be written as 280 by 3 into sigma CBC. The compressive force is acting at a distance of x by 3 from the top of the beam. Compressive force is C. The tensile force is acting at here. It is capital T. For equilibrium condition, equate compressive force to tensile force. C is equal to T. Compressive force is equal to the stress in the compression zone into area of the beam section in the compression zone. That is half into sigma CBC. This is the stress. Area is B into X. See, this is the compression zone up to this depth x. So area is B into X. Tension force is tensile stress into area of the reinforcement. Tensile stress is sigma CST, which is equal to 0.87 into Fy. So stress is 0.87 into Fy into area steel. Multiply with 1 by D on both sides. 1 by 2 sigma CBC B into X into 1 by D. 0.87 Fy into area steel divided by D. Send this 0.87 this side and B to this side. Therefore 1 by 2 sigma CBC divided by 0.87 Fy into x by d is equal to AST by BD. That is AST by BD is equal to half sigma CBC by 0.87 Fy into x by d. We know x is the critical neutral axis depth is equal to k into d. K is equal to x by d. Substitute this k value here. Therefore, AST by BD is equal to half into sigma CBC by 0.87 Fy into K. We can write 0.87 Fy as sigma steel. Therefore, AST by BD is equal to half into sigma CBC by sigma ST into K. Multiply with 100 on both sides. 100 into AST by BD is equal to 100 into 1 by 2 sigma CBC by sigma steel into K. 100 into AST by BD is known as limiting percentage of steel or critical percentage of steel. Limiting percentage of steel or critical percentage of steel. There it is PT. Therefore, PT is equal to 100 AST by BD. PT is equal to 100 by 2 into K into sigma CBC by sigma ST. That is 50 K sigma CBC by sigma ST. If you know the permissible compressive stress in concrete and permissible tensile stress in steel and K value, we can easily find out the critical percentage of steel.